Hi everyone. In this video we're going to go over the p-value method for determining whether you should reject or fail to reject a null hypothesis. Now the p-value method is an alternate method to use to determine whether you should reject or fail to reject the null hypothesis, as opposed to the method of comparing the test statistic to a critical region. Now for the p-value method, what you're going to do is you're going to calculate a number called the p-value. And you can use Excel or a calculator to do that. And then you're going to compare this number to your significance level alpha. If the p-value is less than alpha, you will reject the null hypothesis. On the other hand, if it is bigger than or equal to alpha, then you will fail to reject the null hypothesis. Now, in this slide right here, we're going to discuss exactly what the p-value is for a hypothesis test. So if you're given a test statistic z, remember that's what you calculate. You take your sample mean and you evaluate x bar minus mu naught divided by sigma over root n. That is your test statistic z. Then the p-value is the probability of getting a test statistic as extreme or more than the one that you calculated, assuming that the null hypothesis is true. So the p-value is calculated differently depending on whether you have a two-tailed hypothesis test or a one-tailed hypothesis test. Now down here we have the definition for it depending on what type of test you're using. So for a two-tailed test, that's where your alternate hypothesis is of this form, mu does not equal mu naught. Then the p-value is the area under the standard normal distribution to the right of the absolute value of z and to the left of negative absolute value z. Now down here we have a graphic for this first case right here. So you have your standard normal curve right here. Now the first thing you do is you calculate your test statistic z and you take its absolute value. You mark the absolute value off right here and negative the absolute value right here. Now if your test statistic is positive, then this is just going to be z, of course, and this is going to be negative z. On the other hand, if your test statistic is negative, then this is going to be z, and this will be negative z over here. Negative of a negative number is positive. So one of these values is going to be your test statistic, and the other value will be negative of your test statistic. Now the p-value is the area that we have shaded right here. It's this shaded region. So it's the probability of getting a test statistic as extreme or more, see going in this direction or this direction, than the one that you calculated. And that's it. That's what the p-value is. And like I mentioned previously, you can use Excel or a calculator to evaluate the p-value, and we'll go over that in a second, how to do that. Now if your alternate hypothesis is of this form, this is a right-tailed test, then the p-value equals the area under the standard normal curve to the right of z. So right here we have a right-tailed test. Here's the illustration for this case. Here's your standard normal curve. You calculate your test statistic right there. The p-value is the area under the standard normal curve to the right of the test statistic that you calculated. So that's it. That's all the p-value is in that case. Then for a left-tailed test where your alternate hypothesis looks like this, the p-value is going to be the area under the standard normal curve to the left of your test statistic like we have calculated here. Now based on this, we see that we will reject or fail to reject the null hypothesis depending on whether the p-value is bigger than your significance level or less than your significance level. Let's take a look at that on the next slide and you'll understand that a little better. Now, for a given significance level alpha, if your p-value is less than your significance level alpha, then that correlates to the test statistic z being in the critical region. So you would reject H naught. So we can use the p-value to quickly determine whether we should reject or fail to reject a null hypothesis. Now, to see why the p-value being less than alpha correlates to this test statistic z being in the critical region, take a look at this graphic down here. Okay, so take note of this. This is for a right-tailed test, but the other two tests look similar. So right here is your critical value z alpha, right here. Now keep in mind the area to the right of z alpha under your standard normal curve, that's going to be alpha. So the area to the right of z alpha is alpha. So if your p-value comes up to be less than alpha, then that means that your test statistic has to be to the right of z alpha. See, for this purple area to be less than alpha, the z has to lie to the right of z alpha. And so since in this case here we have z being larger than z alpha, we would reject the null hypothesis. Now if your p-value is bigger than or equal to alpha, then the z would have to lie over here in the fail to reject region. So we see, based on this, if your p-value is less than alpha, you reject the null hypothesis, and if the p-value is bigger than alpha, you fail to reject. And that's it. That's all you have to do. So when you use the p-value method for hypothesis testing, you calculate your test statistic z, then you calculate from that your p-value, then you compare your p-value to alpha. If it's smaller than alpha, you reject the null hypothesis. If it's larger than alpha, you fail to reject the null hypothesis. Now, how do you calculate that p-value? Well, you can use Excel or a calculator. And if you look back at the summary sheet for hypothesis testing, you'll notice that we have the commands that you type into Excel to evaluate the p-value. And that's also on the formula sheet that's available for the whole course. Now let's take a look at this example. Now we're going to consider the previous Jamestown Steel Company example here. And we want to use the p-value method to determine whether we should reject or fail to reject the null hypothesis. So let's go back to that example. So if you want to, you can quickly review this example that we did previously. So recall that the weekly production of desks averaged 200 desks per week with a standard deviation of 16, and new machinery and employees were hired, and you would like to determine if there's been a change in the weekly production. During the first 50 weeks after the new machinery and hires, the mean weekly production was 203.5. Assuming that the population standard deviation is 16 remains unchanged, test the hypothesis that the mean weekly production per week has changed at the 0.01 level. So now this was our answer that we had previously. So recall for this problem the n was 50. The sample mean was 203.5. That was given to us. Sigma is 16. Alpha is 0.01. Our test statistic that we calculated was 1.547. That came from evaluating this quantity right here, just plugging all our information in. X bar, 203.5, mu naught was 200, sigma was 16, n was 50. Plug that in, there's your test statistic. Now, from here, you want to calculate your p-value. All right, so the command to do that in Excel is given in the summary slide, or it's on the formula sheet. So let's go back and take a look at that command. It's right here. So right here's the command that you would type into Excel. Now notice this is a two-tailed test that we're dealing with here. We had a two-tailed test for that problem. So mu was equal to 200. And we were testing against the alternate that mu does not equal 200, recall. So this is our command that we use right here. If we had a right-tailed test, we would use this command. If we had a left-tailed test, we would use this command. So with z equaling 1.547, let's evaluate this using Excel. And I'll show you how to do that here. Now here we have an Excel spreadsheet. Just pick a cell somewhere, like right here, and the command is equals 2 times norm.dist. Now you want negative the absolute value of your test statistic. So negative 1.547. And then the mean for the standard normal distribution is 0. The variance is 1, and then you always want 1 when at the end when you're using the norm.dist function for cumulative. That tells you Excel to give us back an area, that last 1. So there's the command that you would type in. Hit enter. There's your p-value, 0.12186. Now you'll notice that that number is bigger than alpha. Alpha is 0.01, remember? Okay, recall that for our problem the alpha was 0.01. We were testing at the 99% confidence level, so our significance level was 0.01. And so we see that our p-value here is bigger than alpha. And so because our p-value is larger than our significance level, we fail to reject the null hypothesis. And there you go. That's how you use the p-value to perform a hypothesis test. Now let's take a look at this example from our WebWork homework sets. So here, a courier service advertises that its average delivery time is less than 3 hours for deliveries in the Vancouver area. Now let's assume that the distribution of delivery times is known to be approximately normal, with a standard deviation of 1.1 hours. So that's actually our population standard deviation. Now a random sample of 24 deliveries yielded a sample mean delivery time of 3.48 hours, which you see is larger than 3. Now what we want to do is test whether or not the courier service is being truthful in its advertising. So to do that, we will consider a test with the null hypothesis being that the population mean is 3 against the one-sided alternative that the population mean delivery time is greater than 3. So let's set up our hypothesis test now. Now let's identify all the variables in this problem. So you notice that we have the population standard deviation stated to be 1.1. So that's sigma. We also have a random sample of 24 deliveries. So that's our sample size n. and the sample mean came out to be 3.48, so that's our X bar. Now we need to set up our null and alternate hypotheses. So our null hypothesis, we are told here that we should use the null hypothesis that mu equals 3. That's what we're told right here in the problem. So the 3 is actually our mu naught, so take note of that. Our mu naught here is 3. And our alternate, we are told it should be mu is greater than 3. So you see, the way we have this hypothesis test set up is if we support the alternate, which is equivalent to rejecting the null, then we would say that the data does not support the claim that the average delivery time is less than 3 hours. So that's the way this is set up. Now you might wonder, why do we set it up like this and not like this? Now the reason we don't set it up like this is because when we set it up like this, we are giving the company the benefit of the doubt. So the burden is on us to prove that the company is not being truthful in its advertising. And we would conclude that if we reject the null hypothesis, which is equivalent to supporting the alternate hypothesis. If we were to set it up like this, where the alternate is that the mean delivery time is less than 3, then the burden of proof is on the company, which in this case is not really completely fair because, for example, suppose that the population mean is 2.99. Suppose that that's true. Well, in that case, with a sample size of 24, it would be pretty unlikely that we are going to reject the null hypothesis and support the alternate. It would be unlikely for that to happen, even though the company is being truthful. 2.99 is definitely less than 3. So you see, it's a little more fair to set it up like this, where we are giving the company the benefit of the doubt, and the burden of proof is on our survey to conclude that the company is not being truthful in its advertising. Now we need to determine our test statistic and the p-value. And then we're going to perform a hypothesis test at the 5% significance level and also at the 1% significance level. And we'll also note the difference between those two. Now to calculate our test statistic and the p-value, let's go back to our summary sheet for hypothesis testing when the population standard deviation is known, and quickly review the formulas for those two calculations. Now here's our summary for hypothesis testing for a population mean when the population standard deviation sigma is known. Now for our problem, we have a right-tailed test where the null hypothesis is mu equals 3, so the mu naught is 3 in this case. And the alternate is mu is greater than 3. Here is our test statistic right here, where the X bar is 3.48. The mu naught is 3. The sigma is 1.1. And the n is 24. So we just have to plug those numbers in and calculate our test statistic. And then right over here is the formula that we would type into Excel to calculate the p-value. And then we can compare the p-value to the significance level and determine whether we should reject or fail to reject the null hypothesis. Now let's open up Excel and calculate our test statistic and our p-value. So here we have Excel open. Let's just label a test statistic here. And let's put our p-value down here. Okay, so our test statistic, that is going to be equals x bar, which is 3.48, minus mu naught, which is 3. Now we have to take that and divide by, now be careful, we need parentheses around our denominator, sigma, which is 1.1, divided by the square root of 24. And there is our formula for the test statistic. Just take note of that. Once again, you see right here 3.48, that's the x bar, 3 is the mu naught, 1.1 is the population standard deviation sigma, and 24 is the sample size n. Make sure you put parentheses around the numerator and denominator. Be very careful, you will get the wrong answer if you don't do that. Now we just have to hit enter here, and there is our test statistic, 2.138 approximately. Now our p-value, we just have to type in this formula, equals 1 minus norm.dist Okay, now we need our test statistic. That's what that little X right there is referring to. Now our test statistic is in cell B4. So instead of typing in 2.137 and incurring some round-off error, to avoid round-off error, I'm just going to type in B4. That will pull that value in, and then I can avoid any round-off error. Comma 0, comma 1. That is the mean and standard deviation for the standard normal distribution. And then comma 1 for cumulative. We always use that 1 at the end when we're using norm.dist. And there's our p-value, 0.0163 approximately. Now let's take note of those and go back to our problem. So here we are back at our problem again. And recall that using Excel, we calculated that our test statistic was 2.13774. I will take that to 5 decimal places. And our p-value came out to be 0.01627. Okay, so those are the two values that we can enter in here. Now, let's take a look at the answers to part C and D. Now, we want to determine if we should reject or fail to reject the null hypothesis. Now recall we had set up our null hypothesis that was mu equals 3, and our alternate was mu is greater than 3. If we support the alternate, then we are refuting the company's claim. Now, at the 5% significance level, what should we do? Well, at that level, our alpha is 0.05. And notice that our p-value is less than alpha. So notice that the 0.01627 is definitely less than 0.05, where that is our alpha, and this is our p-value. So because of this, we reject the null hypothesis and we support the alternate hypothesis. So at the 5% significance level, we would say that the data does not support the company's claim that the average delivery time is less than 3 hours. So in this case, we will reject the null hypothesis. So let's take note of that. So we'll just click that, reject the null hypothesis. Now, at the 0.1 significance level, what do we do? Well, in that case, our alpha is 0.01. Now you notice in this case, actually our p-value is not less than alpha. So our p-value is 0.1627, of course, and that is actually bigger than 0.01. So our p-value is actually greater than alpha. So in this case, we fail to reject H0. And there you go. So we failed to reject the null hypothesis in this case. And so at the 1% significance level, we have no reason to believe that the company's claim is false. And so let's take note here that we would click do not reject the null hypothesis. And just take note of something down here. You see the difference between these two, the 5% and the 1%. As your significance level decreases, so we went from 0.05 to 0.01, it becomes less likely that the null hypothesis will be rejected. So you see here we did reject the null hypothesis. And here we failed to reject the null hypothesis. So in other words, as your significance level decreases, in order to reject H0, the data needs to be more strongly weighted towards supporting the alternate hypothesis H1. So in this case down here at the significance level of 0.01, our data is just not strong enough to reject the null hypothesis, but it is strong enough at the 0.05 significance level. So take note of that. And then also remember to finish off this problem up here. You need to type in your values up here. So we could type in 2 point right there, and down here. Now just one note, you can type the test statistic in like this, but also keep in mind that with web work you can type your answer in like this, just like we did with Excel. And you see that's just like we typed with Excel, except we don't have the equals in front, and that'll be the exact value. Then you don't have to worry about round off errors. And let's just check our answers down here. And yes, looks like we got everything correct. And there you go. So that is an example with hypothesis testing where we had a right-tailed test and we calculated the p-value.